If I can figure it out, you too can figure it out. With simple motive, let's begin our discussion toward tolerance. Okay, now getting in detail about before getting in detail about tolerance, let us see what tolerance means. What is tolerance? Simply, tolerance means decrease in response of immune system to antigen. Okay, the one line statement, decrease in what? Response of immune system to antigen. Till now, up to now, that means we have discussed various things. We have discussed different type of hypersensitivity reactions. In that, what we were doing is we were trying to produce antibody against antigen, right? But here what we are talking about is, we are talking about decrease in response of immune system to antigen. Why there should be decrease in response of immune system to antigen? Because we need to know that antigen are of two types. One is free antigen, or we can say one is foreign antigen, and another is self antigen. And these self antigen, these are the component of our one body. That means if we will produce antibody against our one antigen, then obviously they will start killing what? Our one organs, our one cells, our one tissue. So we need to prevent this action. Okay, this is we need to prevent this action. That means we need to prevent the production of antibody against our one antigen. That means we need self tolerance, right? And this, to prevent this is called self tolerance. Okay, here okay, I would like to repeat it again. Here what we are talking about is self tolerance. That means we are preventing our self antigen to be attacked from antibody, right? Or to be attacked from the antibody that are produced in our one body. Okay, if there will be disturbance on this mechanism, then there will be several complications like autoimmune diseases, and that is what it is. So we have known a little bit about tolerance. Now, okay, what is the self tolerance? That means preventing, or we can, what is the self tolerance? If tolerance was decrease in response of immune system to antigen was the tolerance, then what is self tolerance? Obviously decrease in response of immune system to what? Self antigen. That's all. That is what the self tolerance is. Okay, now talking about the different type of tolerance. Now there are two type of tolerance. What are the two type of tolerance? Okay, two types. Talking about two types. Okay, talking about two types. The first type is central tolerance. Okay, what I'm saying is the central tolerance. Okay, one is talking about two types. The one is central tolerance and another is what? Peripheral tolerance. Okay, we'll mention it later on, but right now we will be discussing towards central tolerance. The word central in central tolerance means what? The word central means the center for lymphocytes. What I'm saying is center for lymphocytes. Okay, what are the central organ for lymphocytes? For B lymphocyte, the central organ is what? Bone marrow, right? And for T lymphocyte, what is the central organ? That is thymus. That means in central tolerance we are talking about bone marrow and thymus, right? We are talking about the tolerance in bone marrow and thymus. Okay, now let us talk about, okay, suppose the central tolerance means we don't want the presence of any self-reacting antigen or self-reacting T and B cell in central lymphoid organs. That means we don't want any of the self-reacting antigen or T cell or B cell in these regions. In which regions? In bone marrow and thymus, the central region for lymphocytes. Okay, that is all. Okay, what will happen if there will be the presence of self-reacting antigen in these places? Obviously, we would like to remove it from that region. And how we will remove that? We would like to remove it obviously because why we would like to remove it? We would like to remove it because if it will remain there for a longer time, then it will cause the tissue destruction or bone marrow or thymus destruction. So it must be removed from there. And how we will remove? And there are several mechanisms how it will be removed. Okay, such as the first mechanism that we will be talking about is how it will be removed. The first mechanism is deletion. That means deletion. That means such self-reacting antigens or T cells or B cells will be deleted. And another process how it will be done is it will done by what? Negative selection, right? By what? Negative selection. Negative selection. Okay, let us proceed forward by taking one example, and here's the example is okay. There is T cell that is present in thymus, right? It is self-reacting T cell. Now it should be removed. How it will be removed? It will be removed through the process of negative selection. Okay, T cell will go the process of negative selection. Negative selection. Okay. Right? T cell will go through the process of negative selection. There is one important feature on T cell that it has one gene. And what is that gene called? What is that one gene called? The name of gene is AIR gene, AIRG. And what is this AIRG? It is autoimmune regulator gene. Autoimmune regulator gene. And what is this autoimmune regulator gene doing? The autoimmune regulator gene is helping this T cell with the process of negative selection. That means because of this AIRG gene, these self-reacting T cells are being removed from the body, right? These are being removed from the body. If this gene will not, okay, if there won't be this gene, okay, let's say by chance this gene got altered, what happens is this gene got altered. When this gene will get altered, then obviously there will be presence of self-reacting T cells in our what? Thymus. And because of what? Because of that, there will be arising a condition of autoimmune diseases. And what is that autoimmune disease called? It is autoimmune polyendocrinopathy. What I said is, if this AIRG, autoimmune regulator gene, is altered, then there will be the condition of autoimmune polyendocrinopathy. Okay, now, okay, we have already learned the process through which there will be removal of self-reacting antigen from different central sites. Now let us focus on another procedure how these self-reacting antigen are removed. Okay, the another procedure that we will be discussing is receptor editing. What I said is receptor editing. Okay, from the name it is clear. I mean there is edit in the receptors. Now let us make ourselves clear. Okay, through this process what our B cells, self-reacting B cells, are especially removed. Okay, now suppose we have cell which whose receptor are able to identify self antigen. We have cell which are able to recognize self antigen. Receptor will come in contact with the self antigen and the body will change the configuration of receptor. As body will change the configuration of receptor, the next time the same receptor can't bind to the antigen that it was binding earlier. That means there won't be any use of it. Okay, Okay, now let us just focus right here. We will know it so well through this diagram, the diagram from 10th edition Robbins. Okay, here we are talking about what? Central tolerance. And while talking about central tolerance, you can see the T cells are undergoing the process of deletions. The self-reacting T cells are undergoing the process of deletions. You can see in B cells, these B cells are also undergoing the process of deletion, and here you can see the receptor editing, right? You can see here the receptor editing. And what is happening here is these receptors which are on the surface of B cells, right? And these were for recognizing what? Self-antigen. Now these are altered. You can see the structure. Here it was in a C format, right? And here you can see it is a slightly in V format. That means now these receptors are edited, and this is one mechanism through which we gain central tolerance. Now, as we have discussed about central tolerance, now we would like to head toward what? We would like to head toward another type. And what is the another type? The another type is peripheral tolerance. Peripheral tolerance. Okay, talking about peripheral tolerance, at the time we are saying that the above one, we were saying the center refers to what? Center for lymphocytes, right? For B, bone marrow, and for T, thymus. Now here, what is this peripheral? Peripheral obviously means the circulations, right? In circulations, our central tolerance is not 100% correct, or it is not 100% functioning, because of which some of the self-reacting T cells and B cells, they get into peripheral circulations. And at that time, what we need to do is we need to maintain the peripheral tolerance, right, to keep our body organelles or body cells in good functioning way, right? Okay, peripheral tolerance. What is this peripheral tolerance? It is the mistake of central tolerance, right? Self-reacting T cell and B cell enter into systemic circulation or peripheral circulations. Okay, now how we can manage this peripheral tolerance? We can manage it by the following things. So at first we would like to mention what? Energy. What is energy? Energy simply means reduction in function, right? Or we can say functionless, or we can say functional hyporesponsiveness. That means functionally it has reduced its responsiveness. So energy, what is the energy? Energy is functional hyporesponsiveness. Right? Functional hyporesponsiveness. And now let us talk about the mechanism through which this energy takes place. Okay, its mechanism. Talking about the mechanism of energy. Okay, what we have got right now? We have got self-antigen, right? This is what? This is self-antigen. Where it is? It is revolving in peripheral circulation. This is our self-antigen. This self-antigen, the expression of this self-antigen causes interaction between two molecules. And what are these two molecules? These are CTLA4 and PD1. Okay, now what we are saying is this self-antigen causes what I'm saying is these self-antigen are expressed right on peripheral circulation, and when these self-antigen are expressed in circulation, this will cause what? This will cause these two molecules to interact, right? Interaction between these two molecules. Okay, interaction. Now what is the important? Why we are talking about these two molecules here? Self-antigens, we know we are dealing with self-antigen from the beginning of lecture, but why these two molecules? These two molecules are important because these two molecules act as reverse gear. Okay, what I'm saying, these acts as reverse gear, right? Reverse gear of what? Reverse gear of T cell maturations. That means these will not allowed T cell to move further, right? That means it will not allow T cell to get activated, and as this T cell won't get activated, obviously there won't be any destruction, and that is its main motto, right? That is its main motto. And there are other example of energy, other process that will lead to energy. Now here we'll talk about this. Okay, the decrease in interaction between B7 and CD28, and we have learned these things in our B cell and T cell lecture. Okay, what I'm saying is decrease in interactions. What I'm saying here is decrease in interaction, right? Interaction between what? Between B7 and what? CD28 molecule. And these, if you recall the fact that these two were responsible for causing what? Co-stimulatory signal, right? Co-stimulatory signal. Okay, look here. Decrease in interaction between B7 and CD28. What this will cause? This will cause no co-stimulatory signal, because of which T cell will not be completely activated, and that condition we described it as T cell energy. Okay, right? Okay, that was it. Now talking about another condition. Another condition is the condition in which there is decrease in interaction between what? CD40 and CD40 ligand. Okay, this was also previously already discussed one, right? This is also discussed previously. This was the component of B cell, this was the component of T cell, right? And these two were interacting with each other to produce what? Interleukin 4, interleukin 5, right? And these were responsible for what? These were responsible for what? Responsible for antibody switching, if you remember it. Okay, if there will be less decrease in interaction between CD40 and CD40 ligand, then there will be B cell energy, right? I've already said energy means what? Energy means functional hyporesponsiveness. That's all. Okay, now this was, and we were talking about these things under the topic of energy. Now let's move further, right? And talking about another mechanism through which we gain peripheral tolerance is T regulatory cells. What I said is T regulatory cells. Okay, now what are these T regulatory cells, right? These T regulatory cells are the example of CD4 cells. What are CD4 T cells? CD4 T cells are helper T cells, right? Okay, these are the example of what? Example of CD4. Okay, let me write it a bit bolder. What are these? These are example of CD4 T cells, right? Okay, now these CD4 T cells, right? These CD4 T cells have high expression of these molecules. What molecules? These molecules. The CD4 T cells have high expression of CD25 and FOX, right? FOXP3 genes. Okay. Now what these two molecules, okay, you can see what these two will cause is they will enhance the secretion of interleukin 10, tumor growth factor beta, right? This will cause what? These two components will cause secretion of these two things, and these two things, if we recall the lecture on inflammation, then we will know that these two are anti-inflammatory cytokines, right? Okay, this is it. Now These, okay, I would like to recall it. I would like to again go through these T regulatory cells. These are the example of what? CD4 T cells. CD4 T cells have high expression of what? CD25 and FOXP3 gene on their surface, right? And these two genes, what they are doing is they are secreting interleukin 10 and tumor growth factor beta, right? And these are anti-inflammatory cytokines. Okay, now there is another function that these two are performing, and another function is these two induce the activity of CTLA4 and PD1. Okay, we have seen these two molecules somewhere. Where we have seen these two molecules? We have seen these two molecules right here, right, which were acting as reverse gear, that were preventing T cells from maturing or from activating, right? Okay, that means if these two molecules, if they will induce the activity, okay, they will induce activity of these two molecules, then obviously they will perform as reverse gear, right? And this is how the T regulatory cells perform their action. Okay, this is how T regulatory cells perform their actions. Okay, now if there are the condition in which there is defect in CD25, right, if there will be defect in CD25, then it will cause autoimmune disorder. And what is that autoimmune disorder? It will increase the prevalence of what? Multiple sclerosis. Okay. Similarly, if there will be a disturbance in this FOXP3 gene, then there will be development of syndrome, and that syndrome is called what? That syndrome is called Apex syndrome. It will increase the incidence of IPEX, Apex syndrome. Okay, what is this Apex syndrome? This Apex syndrome means from it is, okay, IPEX. Now what it stands from I? From I we got immune dysregulation. Immune dysregulation. From P we got polyendocrinopathy. And what we got from E? Enteropathy. And what is this X? It is X-linked syndrome. Okay, right now we are talking about T regulatory cells, and on the T regulatory cells we are talking about what? Different conditions, different defect in different places, right? Okay, now what is the next procedure through which we acquire peripheral tolerance? And the next one is apoptosis of self-reactive B or T cells. It is very simple to understand. Simply apoptosis of what? Self-reactive B or T cells, right? Okay, now obviously we are trying to remove these self-reactive cells. We are trying to remove this self-reactive B and T cells through the process of what? Apoptosis. It is very simple. Now what happens in this process is here in this process there is increase in, right, there is increase in expression of FAS molecules, right? As there will be increase in expression of FAS molecules, right, it will interact with its ligand. It will interact with its ligand, FAS ligand, right? And this interaction with this ligand, which will cause what? It will cause the activation of intrinsic pathway for apoptosis, right? Extrinsic pathway for apoptosis. Okay, right? And through this process, obviously self-reactive B cells, and T cells are what? Removed. These are removed. Now let us talk about the final, right? Last but not the least, process through which we acquire peripheral tolerance is antigen sequestratum, right? What I said is antigen, yes, EQUESTRATION, sequestration. What is the meaning of sequestration? The meaning of sequestration is hiding. That means we are hiding antigen, the self antigens. We are hiding the self antigen, and obviously, right, if we hide them, then obviously there won't be antibody formation against them. Now there are several organs in our body that helps in antigen sequestration, or that helps to hide antigen. Now what are these organs? These organs are bet, right? I bet you to memorize these things. Okay, this is simply a mnemonics. From B we get brain, from E we got eye, and from T we got testes, right? Okay, now there is one important clinical correlations that we need to discuss right here is, okay, that means we have got eye, and this eye is hiding antigen. And what is that antigen? That is ocular antigen. Now because of some problem, one of the two eye got trauma, right? It got traumatized, and when one of these two eye got traumatized, then that ocular antigen which was hiding will get exposed to our circulation, peripheral circulation, and as that antigen will get into our circulation, then there will be formation of what? Obviously the reactive antibodies, T cells and B cells. And these antibody will not cause effect on only the eye that was traumatized, but also will affect the another eye, because there also is the same ocular antigen hiding, and the patient have to lose both of the eyes. That is the serious condition, right? That is one of the example of autoimmune disease. Now as we have already discussed about the peripheral tolerance, now several mechanism of peripheral tolerance. Now let us see. Okay, under this peripheral tolerance you can see there is T cell regulator, right? T cell regulator, right? And these are suppressed, I mean the T cells and B cell maturation are being suppressed by T cell regulator. You can see here energies, right? Failure to, the meaning of energy, it is shown failure to respond, right? And here you can see there is T cell energy. You can see we said that T cell energy, what was the cause of T cell energy? T cell energy was caused due to ineffective exposure of B7 and C28. That was the interaction required for co-stimulatory signal, right? If there won't be co-stimulatory signal, then obviously there will be no response of T cells. The T cells won't get activated fully. So that is the condition of T cell energy. And what about B cell energy? And talking about B cell energy, if there will be less interaction between C40 and C40 ligand, then there will be the condition of B cell energy. And this was all about what? The peripheral tolerance. Now let us recall each and every condition that we have discussed till now. Okay, there was central tolerance and there was peripheral tolerance. On the topic of central tolerance, how we are achieving is we were giving what? Negative selection, right? And this negative selection, okay, let me write with, okay, we were discussing what? Negative selection. Okay, and this negative selection was done with the help of which gene? AIRE gene, right? AIRE gene. And this was found on what? T cells. Similarly, we discussed receptor editing, right? And this receptor editing we mainly discussed on B cell, as you can remember, right? And there was deletion. There was deletion. We discussed deletion on both B and T cell, right? Okay. Under the topic of peripheral tolerance, we discussed about several energies. We discussed about several energy. We talked about T regulatory cell, right? We talked about deletion, and this deletion was apoptosis based, which was through FAS ligand. And we talked about various we talked about antigen sequestration, right? We talked about sequestration, okay, sequestration. And this was all about tolerance. We have discussed every point on tolerance. Now after this, the topic that we will be discussing is autoimmune disorders. So this was for today. Have a great time. Thank you.